Hi everyone, this is Ali Asadi, and in this presentation I will go through my uh, final project for EE320 lab, and I have decided to work on analog to digital converter. As we know, we need analog to digital converter for all the sensors, and because sensors are sensing analog values and all the values in nature are analog, and we need to convert them to digital values to be able to use them in our device. There are three main parts for ADC devices: input signal condition circuit, quantization circuit, and output digital logic circuit. Here I explained every block in details, and I'm not gonna go through them. This is just more details about the ADC device's main parts. And to be able to explain how a 4-bit ADC device works, I decided to go step by step from 1-bit ADC, which is a simple comparator, and it has two input pins, V plus and V minus, which if V plus is greater than V minus, then the output voltage will be set to high and vice versa. And here are more detailed formula that how it works, the Opamp formula. And then I went to 2-bit ADC, which has four possible outputs and uses three Opamps, three comparators. And here's the voltage range and its circuit. And here's the truth table. And then the main goal of this project, which is 4-bit ADC, which has 16 unique voltages that should be quantized. Therefore, 15 comparators are employed to do the job. And here's the more details of how it works. The voltage divided evenly by resistor divider network between 15 comparators, and so on and so forth. I explained in more details here, but I want to, instead of going to these details, show the output. This is my design in LT Spice, and I will show how it runs. So here's the circuit that I designed, and in the continue I will show why we need this priority encoder. Now if I run this project, we will see the output, input and output voltages. Here's the input voltage, that is analog, and 4 digital voltages for each beat. So this is the design, and here is output of the comparators through 1 to 16. And here I explained why we need priority encoder, which is required to convert the comparator output to 4-bit binary value. But I decided to use 8 to 3-bit by two of them, and because we don't need to use too many logic gates. And here I explain how it works. And this is an example, 8 to 3-bit priority encoder, which I used this one, and I designed this in LT Spice. And this is the truth table of the encoder. And here, how it works, I explained that since we have 16 comparators, The 8 of them are connected to the voltage range of 0 to 7.5, and the rest, the higher 8 competitors, 7.5 to 15 volts. And I explain more details here. And I just want to go to the output, the result that we have. So we have a analog input, and this is the output. This is the screenshot of the entire project, which I already showed in LT Spice. And further development, I could use a 7 segment LED display to show the output. But since I was not working physically, this is just subject for further development. And in conclusion, in this project, I used my knowledge and I did research to learn deeply how ADC works, and here's the result. Thank you so much for watching.